Hello everyone, let's try again solving problems on the recurrent circuits. And in this case we have this problem. We will use the voltmeter to determine the electromotive force and the voltage across a certain resistance. There were three resistances according to the problem. It is in series connection. You can draw a circuit diagram like this one. This is R1, R2, R3, and according to the problem, it is connected to the EMF, the source, which we do not know. So we just put here a diagram, and that is E. For letter A, we are to determine the value of this E. To be able to do that, we can set up ratio between the voltage and the resistances. So we will use the voltmeter according to the problem to determine the value in R3. Okay, so this is the voltmeter, and the rating that was read is 40 volt. And by the way, the voltmeter has 12,000 ohms. It contains 12,000 ohms. So to be able to have our ratio or the voltage, we know that E, okay, so is to the total resistances, okay, which is RT. You can see here the 40 volts, which is the, let's say, R prime, because you will notice R prime here is actually the parallel of R3 and 12. So that is R3, let me just write it, and 12 kilo ohms. So we can solve it by using our idea of parallel resistor. So we multiply the numerator. In the numerator, the value 12,000 ohms, which is 20,000 ohms or 20 kilo ohms, divided by the addition of the two. So that will be 12 plus 20. If you have your calculator, you will get the value of 7.5 kilo ohms for R prime. Now for RT, the total resistance is, that will be the addition of R1 plus R2 and R prime, this one, the parallel of this one, R prime. But the value, so R1 is 10 and R2 is 15, R prime is 7.5. So that will be simply as R1 plus R2 plus R prime. So R sub T is R1 and R2 is 25 plus 7.5 ohms, kilo ohms. So it will give you 32.5 kilo ohms. So now, knowing this one, so we can now solve for E. Solving now for E, that is 40 volts multiplied by RT, which is 22.5, divided by R prime, which is 7.5 kilo ohms. So if you have your calculator, you can have an answer of 173.33 volts. This will be your value. You have just solved letter A. Now for letter B, let us write it here. Letter B is to determine R3 if the voltmeter is removed. So you are going to remove this one, and then what will be the voltage here at R3? To be able to do that, we just use Ohm's law. The resistance is here, that will be the R sub T, and I is the total current. So your B sub T is actually your E, your RT here. Since that voltmeter was not included, so you just add resistors that is in series. Your RT will be 10 plus 15 plus 20, it will give you 45 kilo ohm. Having that value, you can now solve for the total current, which is E 173.33 divided by 45 kilo ohms. And if you have your calculator, you can solve this current as 3.85 ampere. We have already one. So this will be the current that will be flowing here. This will be your I sub T without the voltmeter. So it means that by Ohm's law, this current will pass through R3. So you can now solve for voltage at R3, which is IT times R3. You have 3.85 ampere times R3, which is 20 kilo ohms. You just multiply that one, 3.85 times 20, it will give you 77.04 volts. Okay, so this will be your final answer. So thank you so much.